Good morning, everybody. Welcome to week 2. We're going to continue on with inequalities and look at some real life situations that involve inequalities. All right, let's go ahead and get started. Switch my screen over. All right, so we did this last week, solving inequalities. And what I'd like you to do right now is go ahead and pause the video, solve these, and then I'm going to have you enter a couple of them into the Edpuzzle so I could check them. All right, let's go ahead and check our answers. So as we've been doing on these problems for part A, what we do is we set this inequality as an equation, and then we're going to go ahead and solve it like we normally do. We have x equals 5. I want to put this on the number line. Since it is a less than, a strict inequality, I'm going to go ahead and put a circle. If it was a greater than, I'd still put a circle, right? I don't include it because it doesn't have the bar underneath it. Now I need to test a point, so I'm going to test 0. I can test any point that I want, but 0 is the most convenient. So I'm going to plug 0 in for x, and I'm going to test to see whether this is true or false. So since -7 is less than -2, that is true. I'm going to shade in this direction, which then tells me my final answer is x is less than 5. So this 5 is where I get this number. That is my answer. This is my answer in the form of a graph. So there's infinitely many solutions here. All right, for part B, I'm going to go ahead and set up the equation. So we have this equals 8m minus 8. I'm going to get all my variables on this side. So I'm going to get -5m. I'm going to move the 2 to the other side. So that's -10. Divide by -5, and I get 2. Again, I'm going to put this on my number line. And this one is a less than or equal to, because that equal to, I'm going to close that dot. I'm still going to test the point 0. So 0 is going to go in there. So 3 times 0 plus 2. And again, I'm checking to see whether this is true or false. So I end up with 2 less than or equal to -8. That's false. 2 is not less than -8. So since this is false, I'm going to shade on this side, which then tells me my inequality is written like that, right? Because all my numbers are greater than 2. That's what that's saying, greater than or equal to 2. All right, let's go on to C. Slide this up a little bit. So this is going to be 2/3 p minus 2 equals -4. In order to solve that, I've got to fraction bust that. So I'm going to multiply everything by 3. I'll multiply both sides by 3. So when I distribute this, the 3's cancel out. I'm left with 2p. Distribute that. It's going to be -6 equals -12. Add 6 to both sides. Divide by 2. So p equals -3. Go ahead and put that on our number line. So this is going to be a greater than. So it's going to be an open dot because it's not an equal to. So I'm going to plug in 0 again. I'm going to test that point. So 2/3 times 0 minus 2. Is that greater than a -4? So is -2 greater than -4? Yes, it is. -2 is more than -4. So this is true. So I'm going to shade on this side. So I've got p is greater than -3. Right? Remember, this is where I get my answer from, right there. All right, and the sign is where the shading is. All right, for D, I have 2 minus 3 times x minus 1 equals this. Distribute the -3. We have to be careful. Negative and a negative make a positive. And we're going to combine like terms. I'm going to bring the x over to the other side, so I end up with -4x. Bring the 5 over to this side, I end up with -12, so x equals 3. That's going to go on my number line. So I've got, this is a closed dot because it's less than or equal to. I'm going to test the point 0. So 0 is this 1, equal to 0 minus 7. So this is going to be 2 minus 3 times, this is just -1. It's going to be 4, so 2 plus 4. So some positive number bigger than 7? It sure is. Or positive number bigger than negative 7. That's true. So this is the direction I'm shading. So x is less than or equal to 3. All right. Box my answers. All right, E. E is written as 9k minus 4 plus 1, 2k minus 3 plus 7k. And I'm going to make this an equal sign. Here we go. I'm going to combine like terms because this is kind of a messy problem. This is going to be 9k minus 3. Uh-oh. What do we know? We got the same thing on both sides. So let's just pause for a second. 9k minus 3, is that less than or equal to 9k minus 3? If I want to continue solving it, I can. I could just get rid of the 3's, right? And then I could minus 9k from both sides and end up with this. Is 0 less than or equal to 0? Well, because there's an equal to, this is always true. Right? So no matter what k I put in, it'll always be true. So in other words, the entire number line is shaded, and it would be considered all real numbers. Right? On this one, we have 3y plus 1 less than 3y plus 1. We're ending up in that same situation where we end up with 0 less than 0. Now that's never true because 0 can't be less than 0. So in this case, the number line is left open and there's no solution. So here's the key. If it's always true, in this case with the equal sign, it's going to be all real numbers. If it's never true, then there's no answer that will work, so it will be no solution. That's something we want to make sure that we have in our notes somewhere and that that's clear. All right? All right, go ahead and flip the page. There's a lot of reading on this one, but no big deal. This actually isn't a big problem. There's just a lot of information in here. So in 1912, Japan gave the United States several thousand flowering cherry trees as a symbol of their friendship. Similarly, the nation of Cameroon plans to give flowering sata trees to other countries this year. We asked how to decide which sata trees make good gifts. Cameroon's chief arborist explained, "We plant sata trees when they are 6 centimeters tall, and they grow 9 centimeters every year. The trees only flower when they're taller than 150 centimeters. So you can kind of get a feel for how we can model this situation. Do you think this is linear or exponential? That's right, it's linear, right? Because we have a starting value and we have a growth, a linear growth. It grows the same amount every time. It is very important that the trees Cameroon gives flower this year. In other words, they want them to bloom. It would be considered an insult to receive a tree that did not bloom. Luckily, Cameroon has many groves of sata trees from which to select its gifts. How old must the trees be so that they will flower within the year?" All right, so your first question is, discuss with your team, do you think this is an inequality or an equation? Okay, so it is an inequality. So now my next question is, why? Well, it's an inequality because we're asking them, when are they going to be happy? They're going to be happy if it's over 150, right? It's taller than 150. So are they going to be happy if it's 160? Sure. Are they going to be happy if it's 170? Sure. So they want a situation where it's going to be 150 or more, right? They want it to look like that. That's why it's an inequality. All right, let's go ahead and write an equation or an inequality and solve it. So we have our tree. It starts at 9 and it's going to grow, oh no, it starts at 6, and it grows 9 centimeters every year. So for each year, it's going to grow 9 centimeters. And we want this to be more than 150. So greater than, is it taller than? Yeah, so it's, if I want it taller than 150, I'm not going to be happy if it's 150, so I'm going to get rid of that. Right, so this is my inequality. I'm going to write it in blue just so it's a little bit darker. This should be just a greater than 150. That's ugly. All right, let's go ahead and solve it. So we solve it like normal. 6 plus 9y equals 150. Get the 6 over to the other side. So it's 144. So 144 divided by 9. So 16. So this is in terms of years. So in 16 years, and I want this to be, I've got to decide whether it's going to be the shading. We already know it's going to be more than 16. But let's go ahead and see why. So if I plug in 0, let's test out 0. Is 6 greater than 150? No, that's false. So this is the side I'm going to shade. So I want x to be greater than 16 years. All right. Later, the arborist added, I almost forgot to tell you, when the trees become very old, they stop flowering. Make sure you choose trees that are no more than 240 centimeters tall. Which inequality sign do you think that is? Yeah, hopefully you said this one. So we want it no more. So it could be up to 240, but it can't be greater than 240. Right, so now we can set up another equation. We have 6 plus 9y less than or equal to 240. Let's go ahead and solve this one. 6 plus 9y equals 240 minus the 6. So 234. Y equals 234 divided by 9, 26. So it has to be less than 26. So if it's got to be less than 26, but more than 16, you actually looked at a problem that was kind of like that. Right? It has to be between 16 and 26 years, but you can include 26. So here's how I can write this. X has to be between 16 and 26. I use y here, so let's just change it to y, where y represents the number of years. Or you could just write two inequalities. Right, y has to be more than 16, y has to be less than 26. That's it. All right, if you have any questions, make sure you ask your teacher, and go ahead and send me a question if you have a question right now, all right? All right, see you in a couple days.